we often mention reports, studies, publications, etc. Most of these resources are listed on Papaco's website, which I am going to briefly present to you here. To start, simply go to papaco.org. As you can see, our website hosts all kinds of information on our training, online, on-site, publications, but also our projects, such as the Green List, new technologies, and a page on job and other resources. The publication part is particularly important for our MOOCs, and you can see it includes several tabs, one on resources, one on evaluations of protected areas, which I invite you to screen, and the NAPA newsletter. In the resources on PA's tab, you will find all sorts of reports, studies, and so on. These resources are organized by theme. If you are interested in a particular theme, I invite you to make a Ctrl+F search. For instance, if I search for heritage, I will find the publication related to World Heritage. The NAPA tab lists all the NAPA Papaco has ever published. Please note that before 2010, the letters were only in French. Once again, the theme is here, and you can do a Ctrl+F search on this page. Stay in touch on Facebook, and finally, if you wish to receive the NAPA newsletter by email, please let us know at this address.
Hello, welcome to the first module of our MOOC on the valorization of protected area resources. In the next few sessions, we'll be describing a range of ecosystem services that come from protected areas and how these might best be managed. The module is made up of 8 different sessions. It's the first of 3 modules on protected areas and ecosystem services. First session just provides you with some definitions of things we'll be talking about: ecosystems, ecosystem services, protected areas, and how all of these fit together. In effect, this means we'll be talking about the benefits that flow from ecosystems in protected areas, ranging from their role to helping secure food and water security, through to less measurable but still very important benefits from cultural, spiritual, and aesthetic perspectives. Session 2 will describe ecosystem services in more detail by breaking them down into 4 broad categories and then looking at each of these in turn. There are literally dozens of ecosystem services, and we will be focusing on the most important. Section 3 looks at various aspects of food security and how protected areas can contribute. And Section 4 considers water security, by which we mean the total quantity of water, its quality, and the regularity with which it is available for us to use. Section 5 focuses on human security, particularly the role of natural ecosystems in disaster risk reduction, but also links to our own health. Section 6 considers the incredibly important issue of mitigating and adapting to climate change, and how protected areas contribute to this vital challenge. The final session, Section 7, looks at how protected areas supply more intangible benefits in terms of places to relax, sites important for particular religions and faiths, and places of beauty and contemplation. Each session is accompanied by some suggested reading and sometimes videos. We know everyone's busy, and to focus on the key texts that will give you enough information, and then some accompanying tests to see if you've really understood the essentials of the course. Each module should take about 10 hours of work and complete, including watching these presentations.
compulsory.
Greetings. This module looks at the role that protected areas can and do play in supplying ecosystem services. Let's first look at some important definitions. What is an ecosystem? An ecosystem is a community made up of living plants and animals, along with non-living components such as air, water, and soil. The various components are not isolated, but they interact with each other in complex ways we still often don't fully understand. Plants use the sun's energy and minerals from the soil in order to grow, and animals gain energy from eating plants or eating animals that have themselves eaten plants, and so on. They reproduce, interact, and cycle nutrients and energy. Most ecosystems also periodically go through change and regeneration, such as when a fire comes through a forest or a storm disturbs the coral reef. Human beings, you and me, have already changed most ecosystems on the planet by removing some species, by adding species that were not originally present, by releasing air and water pollutants over huge areas, by fragmenting ecosystems with farmland, forestry, cities and roads, or in more complicated ways, such as changing the processes by which ecosystems regenerate over time. We use terms like natural ecosystem to describe those ecosystems that are more or less like they would be if humans were absent. This is an approximation. As we've said, all ecosystems now show the impact of human interventions in one way or another. However, we use the term cultural ecosystem or cultural landscape, cultural seascape, to describe those that we have altered more dramatically. We'll be considering both natural and cultural ecosystems during this module. Every ecosystem on the planet is different, but we can recognize broad types, often called biomes, like tropical forests, coral reefs, grasslands, and mountain ecosystems. Within these biomes, there'll be many different ecosystems. For example, a tropical forest in Southeast Asia will have different species from a tropical rainforest in South America. But there will be broad similarities. May be confronted with on a day-to-day basis and with monitoring and evaluation. Module 3 considers the social aspects of ecosystem services from protected areas and the rights and benefits of local and more distant communities. We will discuss things like participatory approaches to understanding the range of benefits, free prior informed consent, resource use agreements, distribution of benefits, co-benefit options like payment for ecosystem service schemes, and the critically important issue of managing expectations with relation to these issues. Hello, and welcome to the third session of this module. Protected areas are places where we've made conscious efforts to preserve not just wild species, but also the ecosystems in which species live. Indeed, in some parts of the world, protected areas may be the only natural ecosystems remaining for large areas. The wider socioeconomic and cultural values of the ecosystem services that these places maintain are therefore increasingly being recognised. But until recently, these services have often been taken for granted, and their values underestimated, forgotten, or simply never noticed. The recognition of ecosystem services was boosted in 1997 by a seminal paper from Robert Costanza and colleagues, who noted that ecosystem goods, like food, and services, like waste assimilation, for example, are the benefits that human populations derive from ecosystems' functions. In 2003, the Millennium Ecosystem Assessment suggested a simple framework for summarising the various ecosystem services. In this session, we'll use a version of this framework to look in more detail at the kinds of ecosystem services that come from protected areas. The Millennium Ecosystem Assessment divided ecosystem services into four main types: supporting, provisioning, regulating, and cultural services. There's other ways of dividing up ecosystem services, but we'll use this one as a reference throughout the three modules on ecosystem services. Supporting services. These are the ecosystem processes and functions that keep life on the planet running. Soil formation and nutrient cycling, life cycle maintenance for species providing fish nursery habitats, methods of seed dispersal, and other species interactions, and conservation of a full range of biodiversity. By maintaining healthy and functioning natural ecosystems, protected areas provide services to surrounding managed ecosystems, including farmland and commercial forestry, by supplying healthy soils, abundant pollinators, nutrients, and intercepted solar energy. They also support healthy populations of fish and game that spill over into areas where people fish and hunt. And finally, protected areas maintain baselines of information about natural ecosystem functioning, along with healthy species populations, to support restoration of the rest of the landscape in places where ecosystems have become degraded or destroyed. For example, protecting degraded land from overgrazing or other pressures can allow vegetation to return, soil to build up, and eventually stable ecosystems to develop. Production of desertification and dust storms are two very concrete results that can become apparent in just a few years after protection. This is the principle of the Great Green Wall project in Africa, for example, to halt and reverse human-induced desert formation. Supporting services are often taken for granted, but are the basis of all life. Provisioning services are probably more immediate interest to people. Provisioning services describe the various tangible resources the protected areas either provide directly or help to support. Many of these are discussed in greater detail in other sessions and consist of contributions to food and water security, access to various forms of raw materials, medicines, and other genetic resources. They include both things used directly by local communities and the raw materials for things that may be sold and used far from the protected area itself, such as water flowing from a mountain protected area to a city miles away. An increasing number of protected areas sanction some level of sustainable collection, usually for local communities, focusing on items like poles, building for building and fencing, grasses for thatching, firewood, and more valuable timber for carving, boat building, and so on. Protected areas can also support public health by providing secure sources of medicines, including medicinal herbs that are still the medicine of choice for the majority of the world's poorer people, and by acting as sources for genetic resources for pharmaceutical companies. Regulating services. This refers mainly to the role of natural ecosystems in helping to control the impacts of long-term climate change, weather events, the water cycle, earth movements, and key natural processes that have an impact on agriculture, such as pollination. These values have often been underestimated, but our understanding of the importance is increasing all the time. They include the role of natural ecosystems in both storing and sequestering carbon, and thus reducing the rate of climate change. For many people, this is now a primary reason for conserving natural ecosystems. Ecosystems in protected areas are also cost-effective ways of mitigating extreme weather events and the after effects of major earth movements by protecting coastlines, stabilising soil, and helping to control landslides due to snowfall and avalanche. They can also help to detoxify water and soil to reduce pollution load and associated costs to society. Natural ecosystems supply pollinators to maintain productivity in farms, market gardens and orchards, and can also help to control the spread of some pests and diseases. Not all ecosystem services are utilitarian. We have many cultural, psychological and spiritual links with the natural world. Because protected areas tend to be established in beautiful places, cultural services are strongly represented, and key sites can come to embody the heart of a nation or region in the same way as iconic buildings or religious sites. Recreation and tourism are major drivers of protected area establishment and are addressed in another module. Nature tourism is the largest currency earner in countries like Tanzania, for instance. Protected areas are ideal sites for research, and many have educational programs, giving children an increasingly rare opportunity to interact directly with nature. Doctors and park rangers working together in the Healthy Parks, Healthy People initiative have shown that people with physical and mental health problems or alcohol and other addictions benefit positively from immersion in attractive landscapes within protected areas, safe places for people to go. These also provide rich sources of inspiration for writers, painters and musicians. Many protected areas contain sites of spiritual importance to faiths and religions, and to an increasing extent, resident faith groups within protected areas are becoming actively involved in conservation. Finally, peace parks. Transboundary protected areas along national borders can help build trust and cooperation and have been used to resolve boundary disputes. This is a very rapid overview and a lot to take in. The associated references explain in more detail, and the diagram summarises the range of ecosystem services. Welcome back. This session looks at how protected areas can help achieve food security for local people and for the global community. We'll talk mainly about provisioning and regulating services, ecosystem services that either directly supply food or help create the conditions for its efficient production. First of all, protected areas can be direct sources of food themselves. People often don't realise that many protected areas still permit the collection of some food within their boundaries, as long as this is done in a sustainable way and doesn't undermine nature conservation objectives. So, for instance, local communities are allowed to collect agreed amounts of some plant foods in Bwindi National Park in Uganda. Many marine protected areas allow local fishing communities to keep taking a sustainable catch, whilst banning large-scale commercial fishing operations. If managed correctly, this can directly benefit both local communities and biodiversity. Masali Marine Park in Tanzania is one such example. Many protected areas allow local communities to collect honey from wild colonies. And some protected areas are also managed in ways that support traditional grazing, for example by mobile pastoralists in Air and Tenere nature reserves in Niger, so long as this is kept within levels that do not cause degradation of grasslands. Sometimes a protected area can act as an occasional and emergency source of food in the event of crop failure or drought. The Day Reserve in Djibouti has been acted in this way in the past. Of course, sometimes food collection is also a problem, like the high levels of poaching and illegal bushmeat hunting that is creating the empty park syndrome. Food production from protected areas doesn't mean anything goes, and part of the manager's role is to control illegal extraction. In other cases, strictly protected areas, which allow little or no collection within their borders, are also important food sources because they allow populations of food species to build up and spill over into areas where collection is allowed, boosting overall availability of wild food. This has been found in many marine protected areas, for example, particularly if they protect places where fish spawn and young fish grow to maturity. Protecting areas around mangrove forests, for instance, can increase fish populations in the wider coastal waters. Whereas if people fish everywhere, overall populations decline and the fish caught also become smaller on average. It can take time to convince fishing communities that if they set aside one part of their fishing grounds, they will have more fish overall. But there are plenty of examples to show this can happen and does happen. Some systems have been developed through experience by fishing communities and have run already successfully for centuries. It's true in freshwaters as well. For example, Lake Malawi National Park results in fish spilling over into the rest of the lake. This can happen on land too, with protected areas helping to rebuild populations like antelope and deer, so that some of them move into the wider landscape and supply a ready source of food for local communities. Local communities can help monitor these benefits, for example, by keeping a record of their catches before and after establishment of a marine protected area. Changes in fish supply after the establishment of a marine protected area are often seen within 3 or 4 years. Today, most food is farmed rather than being collected from the wild. Agricultural scientists are continually developing new varieties of crops and livestock to improve productivity, withstand new pests and diseases, and to be resistant to weather events like droughts and sudden drops in temperature. We still rely largely on genetic material from the wild as a source of breeding. Yet many crop wild relatives and the relatives of domesticated livestock are rare and threatened. Protected areas can provide places where such species survive, thus protecting their unique genetic material. This is already increasingly recognised for crop wild relatives, and special reserves are being established for their protection, for instance in Armenia. Interest in livestock wild relatives is also increasing. The need for crop and livestock breeding is becoming more urgent under climate change, which can upset the whole farming cycle. So protecting wild relatives is more important now than ever. Many protected areas originally set up for other reasons are also useful sources of crop wild relatives. Wild coffee is found in the Bali National Park in Ethiopia, for example. Wild oil palm and its pollinator in Korok National Park in Cameroon. Wild olives in many protected areas in Tunisia, Algeria, and so on. An inventory of potential crop wild relatives should be part of any protected area management plan. Finally, protected areas provide a range of ecosystem services that help to drive agriculture. Natural ecosystems such as mountain forests, sometimes called water towers, provide secure water supplies to farmers downstream, and protected areas and drylands can also help vital water supplies to refill, groundwater supplies to refill and serve for irrigation. Sometimes natural ecosystems impact water supply far away. Africa has some of the world's most iconic water towers. Pollinators such as bees, other insects and some birds play a critical role throughout the world. And protected areas help to maintain healthy populations of these important friends of the farmer. And many pests can be controlled by natural predators, but only if allowed to have somewhere safe to live and breed. For instance, ladybirds eat huge numbers of the aphids that can devastate crops. So, protected areas are not just wasted space for the farmer and grower. They supply food and other food-related services that play a key role in national and international food security. To summarise, protected areas provide food directly, either through permitted collection inside their boundary or through spillover of wild species to the wider environment. They also help crop and livestock breeders with genetic resources from wild relatives. And they keep basic ecosystem services like soil and water available to help keep agriculture viable. Many of these services tend to be taken for granted. It's important for protected area staff to understand and publicise these links and to work with local communities to ensure any food-related uses don't undermine nature conservation. In the next session, we'll be looking in more detail at the closely linked issue of water security. Last time we looked at how protected areas contributed to food security and food production. In this session, we're looking at the closely related issue of water security. The planet has a constant amount of water, but its location, the regularity with which it arrives, and its purity alters over time. Things like pollution, changing climate patterns, more extreme weather events, and the melting of polar ice caps and glaciers are all causing disruption to water supplies, putting people and ecosystems at risk. Over 2/3 of the water that we use goes to agriculture, and irrigation is a critically important element in successful crop production in all dryland areas. At the same time, many people do not have access to clean, safe water. Over a quarter of people on the planet already face problems of water scarcity. Almost 2 billion people still have unsafe water supplies, with a huge associated cost in terms of illness, and particularly in infants and children, unnecessary deaths. Countries have traditionally relied on engineering solutions to address water insecurity and problems of sanitation and pollution. But nature-based solutions are increasingly seen as a viable, cost-effective alternative in many cases, and protected areas play a key role in delivering nature-based water management. Protected areas can help increase water security in 3 main ways: by improving water quality, in a few cases by also increasing the quantity of water available, and by smoothing out fluctuations in supply. Watersheds covered with natural vegetation, particularly forests, release purer water with less sediments and fewer pollutants than those flowing through agricultural grazing land, cities or industrial areas. There are fewer pollutants released into the natural ecosystem to start with, but there are also less soil erosion, and the vegetation itself has a filtering effect. Some city councils now deliberately protect forested watershed to ensure supplies of pure water. Similarly, natural wetlands frequently have a cleaning effect. Some water plants absorb pollutants, and natural processes counteract the impacts of sewage and other forms of pollution. These processes do not sort out all the potential problems, but can radically reduce the investment needed for water purification and can reduce risks to human communities where no treatment is in place. Protected areas are one of the most effective ways of keeping natural vegetation in place and therefore in delivering high quality water supplies. Over 1/3 of the world's largest cities already use forested protected areas as a major source of their water supplies. Examples in Africa include Dar es Salaam, Durban, Abidjan and Ibadan, amongst others. However, this assumes that the protected areas remain intact and in good condition. If they are degraded, many of the water benefits are lost. Chulu Hills in Kenya is a protected area and the main source of water for the rapidly growing coastal city of Mombasa, but is currently being degraded and its water supply is consequently at risk. Understanding about the importance of nature-based water management, quality management is growing, and cities such as Melbourne, New York, Tokyo, Los Angeles and Bogota all consciously manage protected areas for their municipal water supply. This management approach is likely to become more popular during the 21st century. Links between natural ecosystems and water quantity and the amount of water available are more complicated. Many forest ecosystems either do not affect or even reduce the amount of water flowing through the catchment due to uptake by the roots and release of water into the atmosphere. But some forests and a few other ecosystems increase net water flow into the rest of the catchment, and as such can be critical for water supply. Most important are mountain cloud forests. These are forests on mountain slopes where there's heavy cloud and mist. Such forests contain trees and other plants that condense water on their leaves so that it trickles to the ground and through the soil to streams and rivers. If these forests are lost, water supply can rapidly decline, so that their protection is particularly important. But certain other vegetation types can do the same thing, such as paramo vegetation found in parts of the Andes in South America. Cloud forests are found in many parts of tropical Africa, such as Sibian Mountains National Park in Ethiopia. A number are already found in protected areas, and their effective conservation is critical for many of the rapidly growing urban centres in the continent. Further protection of African cloud forests is urgently needed. Just as important as quantity and quality of water is the regularity with which it flows. Climate change is increasing weather extremes, which means that many countries are facing more frequent and more extreme droughts and storms. One place can often experience both, too much and too little water in any one single year, with droughts being followed by huge storms that cause threats to life, farms and property. Balancing the supply of water over time is therefore increasingly important. Natural ecosystems can help. Floodplains literally give water somewhere to disperse without causing damage, so long as they're not being filled with settlements or been dammed. Protecting a floodplain can maintain its flood defence role and also stop developments that could put people at risk. Riverside forests, known as riparian forests, help to physically block and slow water from overflowing rivers, thus protecting nearby farmland and settlements. Forests on steep slopes also help to hold soil together and prevent the disastrous landslides that often accompany heavy rains. Just as important, forests and other vegetation help to store water and release it more gradually over time. This not only helps prevent flooding, but also helps to keep supplies flowing during periods between rainfall. On the other hand, if natural vegetation is destroyed, the chances of flooding, landslides, and catastrophic impacts from drought all increase. To recap, natural ecosystems in protected areas generally supply purer water than other watersheds, thus reducing the costs and infrastructure needed for water purification. This is often the cheapest option available. Ecosystems like cloud forests also increase the net flow of water. Floodplains, riverside forests and forested catchments are amongst the ecosystems that help to regulate water flow. Having looked at food and water security, in the next session we'll consider the wider aspects of human security, including particularly disaster risk reduction. Welcome. We've seen how ecosystem services from protected areas contribute to food security and water security. Here we'll look at the complex ways in which protected areas contribute more generally to human security, particularly through protecting against extreme weather events and earth movements, and their role in protecting human health. You often hear the term natural disaster, but this is misleading. Extreme weather events like storms, droughts, floods, heavy snowfall and tsunamis, along with earthquakes and other earth movements, only become disasters in human terms if and when they impact on us, our livestock and our property. A tidal wave on a deserted area of coastline passes unremarked, as does an earthquake in the middle of an uninhabited desert. Extreme weather events tend to become disasters because we are living in dangerous places or have removed the natural defences that could protect us. This is where protected areas come in. Disaster risk reduction, often shortened to DRR, is a term used to describe the steps we take to prevent an extreme weather event or an earthquake from developing into a disaster. Until recently, DRR experts have focused mainly on engineering solutions, like building seawalls to protect against tsunamis, barriers against avalanches and landslides, or dikes to stop flooding. But in the same way as we've explained for water security, there's increasing interest in nature-based solutions. Disasters include those from exceptionally high winds from tidal waves caused by undersea earth movements known as tsunamis, avalanches and landslides, drought and desertification, wildfire, earthquakes and volcanoes. None of these can always be stopped completely by natural defences, any more than they can be stopped by built defences, but they can be stopped or reduced on many occasions. We'll quickly examine the main ones in turn. High winds and storms, particularly in coastal regions, can devastate agriculture, destroy buildings and kill unlucky people. These kinds of storms are becoming commoner under climate change. Natural coastal barriers, including reefs, sandbars, mangroves and other forests, and coastal salt marshes both block the direct impact of high winds and give somewhere for water to disperse without causing damage. Similarly, coastal communities can be protected to some extent against both sudden influxes of seawater in the form of tidal wave and the gradual rising of sea level due to melting ice caps by the same kinds of barriers that we described above. Comparisons of coastlines with and without natural defences in place show these barriers provide a real measure of protection. Many people in arid countries that have experienced years of overgrazing assume that the remaining landscapes are natural. Natural deserts do occur, of course, They're often much richer in vegetation than many of those found today. Vegetation reduces the rate of spread of sand dunes and desertification and the number and scale of dust storms. Controlling livestock grazing levels is often critical to recovery of these places. Climate change is increasing the rate and intensity of fires. These are particularly dangerous when they occur in ecosystems that are not fire adapted and can cause damage that will take centuries to recover from. Fragmented, degraded ecosystems tend to catch fire more easily than mature ecosystems, such as tropical forests, and therefore maintaining natural ecosystems also helps to reduce the risk of wildfire. We mentioned in the last session that one of the key ecosystem services from protected areas is the role of natural habitats in either blocking floods physically, as happens sometimes with riverside forests, or providing a safe place for water to overspill and be stored. Sudden slippage of earth, rocks and snow can kill people and destroy property. Movement can be caused by heavy rains, by floods, earthquakes and volcanic eruptions. If a slip hits a town or village, the results are catastrophic. There's a depressingly familiar link between deforestation in the uplands and loss of life due to landslides. Research shows that forests on steep slopes dramatically reduce the chances of a slip. This is a very rapid run through potential disasters and the ways in which nature can help protect us. Any natural ecosystem will do the job, but protected areas play a particularly important role because they help retain natural ecosystems in places where there's often high pressure to use land, and therefore where many people are likely to be living. Protected areas also provide an opportunity for restoration of ecosystems, even if these have been degraded or lost. Restoration is difficult and uncertain, but for some ecosystems, including mangroves, for example, we already have a lot of experience in bringing them back and have measured the results in terms of additional human security. So, protected areas help prevent disasters. Not entirely, as we said. An extreme disaster will overwhelm everything, but they will improve everyone's chances. And sometimes it makes sense to combine nature-based and engineering approaches, such as conserving riparian forests along a river, but also building a dike beyond the forest to help block any water that does get through. So far, we've talked in this session mainly about protected areas providing human security against sudden extreme events. But they also have an important role in more everyday aspects, like keeping people healthy. Protected areas, particularly those close to urban areas, can play an important role in providing places for people to exercise in safe, unpolluted and pleasant surroundings, the so-called green gym concept. Many protected areas are working actively with health authorities to promote exercise in nature reserves and national parks. It isn't just physical health. Experience working with mental health authorities shows that many people with mental illnesses or with substance addictions, such as alcohol or other drugs, react positively to being in pleasant rural surroundings, and this can be an important part of their therapy. Getting kids into nature is also incredibly important in a period when many spend their time inside watching television or playing games on their phones. Psychologists talk about nature deficit disorder to describe the problems that can result, and link up between schools and parks can help ensure these problems are avoided. Finally, protected areas play a deeper role in providing medicines. Billions of people around the world still rely primarily on medicines collected directly from the wild, and everyone else relies on medicines that contain products derived from wild genetic material. As natural ecosystems disappear, those inside protected areas play an increasingly important role in providing these products. Many protected areas permit sustainable collection of medicinal herbs by local communities, for instance. They may be the only places where some species are still found. But conversely, overcollection can become a management problem. We've covered a lot of ground in a short time. To summarise, the natural ecosystems maintained in protected areas provide protection against a wide range of extreme weather events and earth movements. Protected areas also help maintain people's health on a day-to-day basis, both by providing a good environment for exercise and relaxation, and as a source of local and global medicines. Through these sessions, we've referred again and again to climate change and the extraordinary impacts that it's having and will continue to have on our lives. In the next session, we'll look more closely at the role of protected areas in addressing climate change impacts. Hello again. The last session was quite long and complicated. This one's a bit shorter and simpler, although we're dealing with a very complex issue, climate change. Everyone knows at least something about climate change, about how burning fossil fuels and other biomass has increased levels of carbon dioxide in the atmosphere, which along with other so-called greenhouse gases produced through human activity, makes the atmosphere act like a gigantic greenhouse, reflecting more of the sun's energy back to the earth again and raising the average temperature. Although the average increase in temperature appears very small at first sight, it's having enormous impacts. This includes melting of ice caps in polar regions and mountain glaciers, changing and more uncertain weather patterns, rising sea levels, ocean acidification, and knock-on effects like movement and extinction of species, spread of pests and diseases, increased fires, and so on. The only real way to tackle climate change is to remove the pollutants that are causing the problem. The well-known agreement in Paris in 2015 was supposed to pave the way for this to happen, but governments are still arguing, and some major polluters are refusing to change. We all face the consequences. Whatever happens now, climate change has come, and we need to learn how to work with it. This is true for protected areas as well. Managers are starting to learn how to address the potential impacts of climate change on their own protected areas, what they can and cannot do to help minimise any damage. It's generally agreed that healthy natural ecosystems will likely be more resistant to climate change impacts than degraded systems. So management effectiveness is very important in dealing with climate change. But it's not only protected areas that face additional problems under climate change. They're also part of the solution. IUCN was one of 6 organisations that produced a report in 2008 looking at ways in which natural ecosystems in protected areas might help the world adjust to and manage the impacts of climate change. Protected areas have 2 key roles here. First, they provide the means to mitigate climate change by storing carbon in soil and vegetation and capturing, sequestering more carbon from the atmosphere. And secondly, they provide a range of ecosystem services that will help us to adapt to the harmful impacts of climate change. We'll discuss adaptation first. Climate change makes a whole range of present-day problems worse by increasing climate uncertainty, spreading new diseases, increasing acidity levels in the oceans, and other changes. It reduces food and water security, brings new health hazards, increases the rates of extreme weather events, drought, and desertification, and generally puts everything under much more pressure. This means that the role of protected areas in supplying ecosystem services, which we have been describing in the previous 6 sessions, is even more important now than before under conditions of climate change. We won't go through these all again here, but just remember that climate change makes all the things we've been talking about earlier, all the ecosystem services from protected areas, even more essential. Around 1/5 of the carbon dioxide released into the atmosphere doesn't come from fossil fuels, but from burning living or more recently dead biomass, particularly forests and peat. Some of this comes from natural fires, others from fires that are a result of climate change, but many from deliberate burning for land clearance, charcoal production, criminal activities, and arson. Anything that keeps carbon in place in vegetation or soil is a benefit, and anything that provides an opportunity for more carbon to be stored is doubly beneficial. Over the last 20 years, we've learned a huge amount about where carbon is stored, how much is stored, and ways in which we can manage ecosystems so that they store and sequester as much carbon as possible. Carbon storage is already a huge business, and it's likely to get bigger. Forests are incredibly important, as clearing forests releases a huge pulse of carbon. Interestingly though, forests continue to store carbon even when they are in mature or in an old growth phase, such as in parts of the Congo Basin, because they continue to build up carbon in the soil. In fact, soil, and particularly peat, is another very major carbon sink. Peat is probably the most important single carbon store on the planet. But any soil is important, and farming methods that minimize soil disturbance or build up organic matter themselves become a climate benefit as opposed to being a climate cost, as other forms of agriculture can be. Grasslands are important too, including the vast savannas and miombo of Africa. Finally, and only recognised relatively recently, the oceans themselves store huge amounts of carbon in algal microorganisms, in kelp, in seagrass beds. Protected areas come in here because they are recognised as efficient and effective ways of keeping vegetation intact. Research shows that at least 15% of terrestrial carbon in vegetation and soils is already in protected areas. The multiple funding mechanisms springing up to encourage carbon storage and sequestration all need to prove that carbon is being stored. Protected areas, with their clear conservation goals, staff, and monitoring systems, are ideal tools to do this. Protected area advocates have spent a long time arguing that the case for protected areas to be included in schemes such as the REDD+ carbon storage scheme, with growing success. That doesn't mean that getting involved in a carbon storage scheme is necessarily easy for a protected area. There'll be plenty of paperwork, additional management activities, and extra scrutiny from people managing those schemes. But governments are increasingly recognising that their protected area network is a potentially easy win in terms of meeting international climate obligations and reduction targets. So to summarise, climate change is coming. Protected areas have to adjust, but they also have a lot to give. Protected areas, particularly those with forest, peat or marine components, have much to offer in terms of carbon storage. And virtually all protected areas also have important things to offer in terms of the ecosystem services that we've been describing throughout these sessions of the module, which will become increasingly important in the future as climate change starts to bite in earnest. That's it for this session. Next time we'll discuss some of the cultural and spiritual services offered by protected areas. So far we've only discussed utilitarian ecosystem services, but humans have many elements and want something much less tangible. We're going to be talking about cultural, historical, spiritual and aesthetic values. Let's start with historical and cultural values. Many protected areas have historical and cultural values running back for centuries. Maintaining these values can be a key benefit of protection. Values can include important prehistoric remains, historic buildings inside protected areas, like the cultural landscape of Lope, Okanda and Kapan, rock art, such as the famous paintings in Solilo World Heritage Site in Botswana, and the Nadi Massif in Chad. Or it can even be traditional forms of land use, like the nomadic grazers that still carry out their traditional lifestyles in the Namib Sand Sea in Namibia. These values can be challenging for managers, and this is where discussion with relevant experts, and even more importantly, with the local communities can help identify the best approach to management. Spiritual values, including those related to particular faiths and religions, are vitally important to local and sometimes also to more distant communities. Spiritual values exist because the protected area contains an important religious building or sacred natural sites. Some sacred natural sites are very old, others are emerging all the time. The presence of such a site can encourage local people to undertake conservation, such as on the small island of Nosy Bay in southern Madagascar, where the presence of 3 sacred natural sites are accompanied by protection of a colony of nesting tropic birds by local fishing communities. Incorporating sacred natural sites into the protected area system, such as this sacred grove in southern Ghana, is a way of helping to ensure that protected areas actually stay protected. Local faith leaders often welcome such moves as conferring additional protection onto their sacred sites. Spiritual or sacred values may also focus down on individual species, and it's important to know what these are and to accommodate this into any management plan. But sacred places and species are not necessarily easy for protected area managers to understand and accommodate. They may, for example, be linked to a religion or a faith that the manager does not follow, may not even understand. Tolerance and empathy are needed here. This issue is so important, that IUCN has prepared special guidance on management of sacred natural sites and protected areas. Now, let's talk about aesthetic values. Protected areas attract artists of all times, as well as people who have no intention of using their visit to create a work of art, but simply want to enjoy being in a place that touches them emotionally. Many of the earliest national parks were set up explicitly for their landscape values, and physical beauty is still a major incentive for protected area establishment. But it's also notoriously hard to quantify. What is the price of a view? The answer almost always depends on the individual. Most protected area managers understand and share aesthetic values and factor them into management. For instance, by giving space for people who enjoy a quiet moment drinking in the view. That's the end of this module on ecosystem services. In the next module, we'll talk about how these services can be managed.